Man, remember that show, Zaboomafoo? That show was great. Okay, what we're here to talk about are adding vectors in a kind of graphical manner, okay? And the way we do this is normally with the ruler and protractor. What we're just going to talk about here is kind of a rudimentary way to do it or to think about it. And what that means is we're just going to be kind of drawing some lines here and taking a look at what they would represent whenever we think about adding vectors. So the first thing I'd like to think us back to is we remember, I've asked this a few times this year, what does 3 plus 4 equal? And everybody says, oh, it equals 7. But some of us say, well, it could equal a lot of different things. And this is the reason why. When we go back to the number line years ago, when you're learning how to count, I can take this number line, I can start it at 0, and yes, I know it goes negative, but let's just say positive. And I can go 1, 2, 3, 4, 5, 6, 7. And if I do 3 plus 4, I'll do 3, well, 1, 2, 3, and then I'll add 4 to that, 1, 2, 3, 4. And that'll take me out to 7. Now, what we're technically doing here is we are adding these two vectors together using something known as the head-tail method. So the head-tail method, what is that? What we're doing is we're taking the head of a vector, which is an arrow point, and we're adding it to the tail of a vector, which is the back end. Okay, we're adding them head to tail. And when we do this, we're going to take 3, and we're going to add it to 4, and that's going to give me 7. Okay? But, as we've seen with vectors in this class, we don't have to add things in the same direction on the same line. If we wanted to, we could say, hey, look, here's a vector of 3, and I'm going to add it using the head-tail method. So if that's the head, there's the tail of the next vector. That's 4. And if this is a 90-degree angle, then what would that add up to? Well, when you add vectors together, they are going to equate to something known as the resultant vector. It is the result, okay? And we think about that as going from the start of the vectors added to the end of the vectors added. So I like to say start to finish. And if we look at our original 3 plus 4, start to finish gives me 7. Woo! If I look at 3 to 4 here, going from the start to the finish, that doesn't give me 7. We quickly see that as a 3, 4, 5 triangle. So in this case, 3 plus 4, or the vectors 3 plus 4, don't equal 7, they equal 5. And if we are even more careful about how we draw things, here's a 3, and here's a 4 going back the other direction. Well, going from start to finish, like this, we see that we have a vector amount of 1. And if we're thinking about directions, maybe we can identify that this is 1 at 180 degrees for a polar notation. Or if I was writing it in a rectangular notation, I could say it's -1, 0. So there's a lot of different ways that we can use the polar, rectangular, unit vector notations. And when we think about adding things in this head-tail method, what we're actually adding does matter here. Okay. Now, it turns out it doesn't matter the order you add up vectors. So if you had something that looked like this, we come over, and then we come up, and then we come over. That's going to give us a nice vector from start to finish that looks like that. It doesn't matter the order in which you add them. If we wanted to, we could have gone up, and then over, and we'd still go start to finish. We could go over, up. So there's all sorts of different ways that you could add the vectors together. The order doesn't matter. Just as 3 plus 4 would equal 7 on a number line, 4 plus 3 equals the same thing. The order doesn't matter. The only thing that matters is you're going from start to finish. Now, what does matter here is, let's pretend we take two vectors real quick. Let's take vector A and vector B. Right now, as they're located, they are set up so that they are tail-tail, which we don't want. So we can actually slide these vectors to get them to add properly. And to slide a vector, I simply take it and I shift it so that it does sit head-tail with another vector. And at this point, I can go from start to finish and draw in that vector line. Now, a neat thing about this is that I don't have to go A plus B, and like I said, we could do B plus A, because if we take a look at these, if I do this, they'll reach the same position. So A plus B is the same as B plus A. What is different, though, is while A plus B and B plus A are the same thing, we do need to be careful about this. What would A minus B equal? Well, really, A minus B is the same as saying A plus the opposite of vector B. And when we think about what is the opposite of vector B, well, the opposite of vector B is vector B here, but it's pointing in the opposite direction. So instead of pointing up and to the right like this, the opposite of B would be pointing down and to the left. This is vector negative B. And if we added A plus negative B, well, we could add that like this. And in that case, we'd go from start to finish out here. So it is important that we recognize, are we doing adding vectors? Are we adding the opposite of vectors, the negative of them? What's going on here, okay? So that's something that we need to think about when we are adding these vectors together and what we're thinking about throughout this. The reason why this is so important is while we won't be doing a lot of graphical stuff in this class, what happens if we have something like in rectangular notation, that is x comma y, what if we have something like 3 comma 4 and we want to add it to another vector, like, I don't know, negative 2 comma 7? How would we add those together? That's kind of a weird thing to do. So what we're going to see in our next video is how we can add things like rectangular vectors together, how we can take polar vectors and put them into something we like a little bit better, and how to take care of unit vector notation as well. But this is really what we're doing. Really think about it as connect the dots. We're just drawing one vector after the next, and wherever we end up, we go from start to finish to get that resultant vector, which will be everything added up together then. Okay? So for now, this is finished. We'll be expanding on this in the next video. But for right now, adios, and take it easy.